All right, welcome to your last physics lesson of new material here. So I'm going to wrap up optics today and then give you some further instructions about what the next few parts will look like and moving into our next unit. But yes, this is going to be where we cover the last important piece of the optics unit and wrap up physics. And that last important piece is talking about mirrors and how mirrors work. So we have a note to start the day. Okay, so let's call this, move my little elephant out of the way, concave and convex mirrors. I should have called it mirrors in general. I'm going to take just a moment to talk about a plane mirror, which is a flat mirror, but then focus the note on these two types of curved mirrors. So the flat mirror you're very familiar with. Flat mirror would what you would look at in a mirror or something like that in your locker. Think back to when you had your locker. If you had a mirror in your locker, it's most likely a plane mirror, which means it was completely flat. So those mirrors work on the basis of reflection and the idea that because it is a flat surface, the light ray going in, whatever angle it comes in at, goes out at that same angle. So like we talked about last week, in reflection, the angle of incidence is the same as the angle of reflection. So that is pretty straightforward with a flat mirror. Now, what you might not realize about that is that means that what you see sort of is flipped around kind of left to right. So you're not flipped around upside down. That would mean that when you looked in the mirror, you looked upside down, but it is flipped left to right. So this makes sense when you think about trying to read like any kind of text that would be on like a hat or clothing or stuff like that. When you see yourself in the mirror, it doesn't read back to you like you see it when you look at it before you put it on. And it's all inverse that way because as it went in, the light ray went in this way, it bounced back this way. So what that means is you always see yourself one way through the mirror, but it's actually opposite of how you look to other people. So this left-right thing is flipped around. A couple of interesting things about that would be that when you see yourself, like right now, I can see myself in the webcam. When they first made those, they showed it to you as how other people see you, and that really was quite confusing for people. It didn't line up with their sense of how they look. And that's because you're seeing yourself inverse of how you see yourself in mirrors. So they flip that around. And now when you look at yourself, you see yourself as you would if you were looking in a mirror. But if you are probably familiar with maybe selfie taking and you know that you're looking at yourself and then you take a picture and it's flipped around because that's what the camera's doing. It's showing back to you how other people see you, not that reflection that you're used to seeing. So that's just with a plane mirror, just that it follows the same principles we talked about with reflection before. The angle it goes in at is the angle it comes out at, and that means you have this kind of thing and it inverses it all in that way. Okay, so where we're going to spend the rest of the time and do our ray diagrams for are curved mirrors. So you can have a mirror that goes like this, kind of curves in, like you're moving in towards a cave kind of idea. And that's where the concave ones are. Or you can have a mirror that bubbles out, okay? And they kind of distort or change the image from just being reflective of what you would see in a plane mirror. So let's get started with these two types. We'll do the concave one first. I'm going to show you how the ray diagrams work, talk about the kind of image you get, and then talk about some applications, which means why you would use a mirror like this, the purpose that it might serve. So we'll do a subtitle here, concave mirror. Right. And once again, I'm going to freehand here today just because it's easier for me to do, but really the ruler would help you do a much, much better job of this. So I'm going to do a principal axis using a line on my page. Oh, see, already started out kind of up and down, but that would be a nice straight line, principal axis once again, just like when we did the lenses. Now, concave mirror, I'm going to draw it from the side. is going to cave in, like I talked about before. So I'm going to try and make this symmetrical. Okay, so the mirror is not facing on, but from the side, you can see that the mirror curves in and then curves back out like that. So this is the reflective side of the mirror, and this is behind the mirror. So sometimes we just use lines like this to show that that is the back of the mirror. Okay, whatever that might look like. And then the reflective side that you see yourself in would be on this side. So we're looking at it sideways, like I said before. So unlike a lens, the light can't get through this, and it doesn't come from both directions. All right. The concave thing we saw before was the diverging lens. So when this was a lens, it kind of went like this, and then you had both sides caving in, and the light could go through this way or it could go through this way. Because this is a mirror, the concave idea is still here, but the light has to come from this side and it's going to bounce off the surface. It can't actually go through. So this kind of mirror, if we look at what is going to happen, is generally light rays are going to hit this, and then it would come back to a focal point, which is somewhere in here. So I'm going to put F there. There's going to be my focal point. Okay, so any parallel ray that comes in is going to bounce back and go to that point. So if you think of like a solar oven or something like that, you have all this high intensity heat that you can direct to this point, and if you put your food right here, that's how you would cook it. So you may have seen or experimented in science in elementary school, or watched a program, or learned about solar ovens and how they work. Usually they might not use, they can use mirrors, but use tinfoil as well. You have this kind of shape to your mirror, and it will focus all that heat into that central point, and it can be used for cooking. All right, so let's say I have an object. I'm going to put it right here outside the focal point. I'm going to use the arrow just because it's just the most simplest thing to do and still show us if the image is right side up or upside down. So rules for this, I'm going to do kind of 1, 2, 3 types of rays we can do. So you're used to seeing this with lenses now. Once again, there's 3 types of light rays that you can choose to draw for any object. 2 of them will show you where the image is and help you describe what that image looks like. So the first thing you can do, and I'm going to shorten it this time instead of using as much text, is you can start by going parallel, just because you've seen this before. So if you start out with a light ray that is parallel to the principal axis, so lines up with that line like this, once it hits the mirror, what it's going to do is turn and go back through F. Okay, so if you use a parallel line to start, when it hits the mirror, it's going to go back through F. If you choose to go through F, you might be able to anticipate what's going to happen here. So the light ray starts at the same point. Instead of going parallel, it starts by traveling through F, hits the mirror. It is going to turn and go back parallel to the principal axis. So let's write that as through F. It's going to go back parallel. Now, the part that's new, and the one I'm going to choose to not use as much, would be that if you're coming into what's called the vertex of the mirror, and this would be the perfect center of the mirror, the vertex right here, if you bring a light ray that comes into that point, it is the point on the mirror, because it's curved, it is the one point on the mirror where the angle of incidence is going to equal the angle of reflection. So whatever angle I come in at, I'm going to bounce off in the same way. I'm not going to use it as much because I have to use a protractor to sort of see what the angle is as it comes into this point called the vertex, and then measure that same angle back out. But I'll show you by freehand roughly how it works. So if the angle, that's our notation for angle, and I'm going to put a little I here for incidence. Let's do this. The angle of incidence equals the angle, little r for reflection, at the vertex. and the vertex is right there. Okay, so I'm just gonna generally show you how to use that, but I'm gonna avoid that one because the protractor and I can use the other two to find the image. So let's come out and go straight towards a mirror. Put a little arrow in there to show where the light ray is coming. And because I started with parallel, I'm going to reflect back through the focus. Okay, option for my second light ray is I'm going to start at the same place on my object. I'm going to come through F towards the mirror. Okay, and then I am going to come back parallel. All right, that is where they crossed. So this is where my image is. That's the top of the, so I started at the top of the object. Where the lines cross is the top of my image. Draw my little straight back. Okay, and put the top on the arrow because crossing is the top of the arrow. Now, if I had used this option, I would have done a straight line that comes in to the vertex, and I would have measured that angle and then made that exact angle as it reflected away from that point, and it would come to the same place here, okay, and keep going. So I could have done that and use that angle of incidence equals angle of reflection at the vertex. That's the only point that'll happen on because of the curved surface, but it involves a tool, and in the event you don't have that tool, you can do it that way. So let's describe the image here using SALT. So I'm going to do over here SALT. The 4 properties of this image. So first of all, it's smaller than the original object. So I'm going to write here that it's smaller. I could measure it if I wanted to. The attitude is whether it's upright and inverted. So it's in the same position as the object or upside down. It's upside down, so we call that inverted. L is for location. So it's on the same side of the mirror, and it's between the object and F. So I'm going to put between object, sorry, I didn't leave myself enough space, and F, comma, same side of mirror. Sorry about that. I should have left myself a whole bunch more room for that. So that says between object and F, same side of mirror. Now T is type. So we have 2 options, real or virtual. So in this case, we have it showing up on the same side here. And so this one is real. Okay, real light rays crossed here to get this. So where would you see something like this, an application like this? This kind of mirror and this kind of situation could be used in something like a telescope. And depending on what you're looking at, you can get the light rays that way. So those telescopes where we couldn't keep putting a lens because the lens was too heavy and you're like hoisting in the air, you can switch to a mirror at the bottom of your telescope and collect the light rays and look for images that way. Okay, so I'm going to put on here, over here at the side, that a place you might see that is a different type of telescope, different than the ones we talked about before, for looking at images. Okay. Now, the next one we're going to do, same type of mirror, but what if your object is between F and the mirror? And where did I put down my little, so I'm still going to freehand my principal axis. They're kind of mimic, same kind of mirror. I'll put F a little bit further just to give me more space. And I'm going to put the object here. Okay, I'm going to move it to between F and the mirror and show you what happens there. Back of the mirror again. All right, start. So light ray headed towards the mirror. And it's going to head back through F. Okay. Now, where the next part is tricky is that there's no F to go through next. So what I could do is I could use this come in, measure the angle, go out, and look for where they meet. But what I'm going to find out is they don't actually come together at this side. Okay, they're traveling away from each other. How this one works, which is going to seem a little more complex to you, maybe, is that I do a light ray as if it's coming from F. So I line up with F, and I come towards the mirror, just a bit, and then I go parallel. These rays also aren't going to meet. So then I'm going to do the trick which you might be familiar with from before, where we extend back from those light rays that are moving away. So this one, I'm going to have a dash line. You always extend from the ones that bounced away, from the ones that reflected. So I came as if I was coming from F because F wasn't on this side, hit the mirror, reflected back. The reflected one is the one I extend. In this case, I came towards the mirror, reflected back through F. The reflected one is the one I extend from. Okay, and there's the point where they meet. So that is the top of my image. And let's describe it. Okay, so this time the image is larger than the original object. It is upright. Okay. It is other side of mirror. And we use these dashed lines here to find it, which means I can see this sort of inside the mirror. It's like when you look at a mirror, you look like you're deep in the mirror. You don't look like you're flat on the surface of the mirror. You look like you're inside the mirror. So this is virtual. And the kind of mirror you would use this for if I'm basically trying to like blow something up and see something bigger. So this might be, and not have it upside down or anything else. This would be like your makeup mirror. A cosmetic mirror, maybe they're called. They tend to be in bathrooms where they're round and maybe haven't noticed, but they're not flat, and they have that magnifying effect where you see yourself, but you see the area you're looking at enlarged within the mirror, not its usual size. Okay, all right. The next thing then is to talk about what about if the mirror goes the other way? What if it bubbles out, and what that looks like? So convex mirror. I'm going to repeat the same thing. I'm going to do it I think I'm just going to do this once, actually. We only do this once because it's going to turn out the same way both times. All right, let's do a line, principal axis. This time, the mirror is going to bubble towards you, towards the object. So this is still the side of the mirror that isn't reflective. It's like the back of the mirror, and then the reflective surface is right here. For these ones, because it bends this way, the focal point is actually somewhere back here. So let's put F on this side, just like your converging lens idea. Converging lens shapes this way. Light can go through it both ways, so you get an F on either side. With a mirror, that's not the case. So we just have it right here. You can probably hear, it's probably school related. I'm going to get that after I'm done though. All right, so let's put the object on this side. Okay, the same side as you're facing the mirror, and see what happens. So we're going to follow the same rules. I'm going to start with a line that comes towards the mirror. We're almost done. I'll get that in a minute. Okay. And then I can't actually continue into the mirror, but my light, sorry, has to flip off the mirror. It's going to flip off the mirror and reflect at the angle as if it was headed towards F. So I'm going to line that up like that. And then I'm going to, bounce away like that. And then I could extend this because I always extend from the reflected. Okay. I pretended like I angled like I would head through F because the light can't actually go into the mirror. Light can only be reflected from the mirror. It reflects off at that angle. And then I trace backwards to find a line. All right, the other thing I can do for a light ray that's going to work pretty simply is head towards F right from the beginning. So I head towards F. I hit the mirror. The light can't go through the mirror. It reflects back parallel to the principal axis. Here we go. And then I'm going to extend back behind the mirror. Okay, so you can see these two reflected rays were never going to meet. So where my image is going to be behind the mirror somewhere. I extended my rays from the ones that reflected. This is where it crossed. So there is my image right there. And we're going to describe it with our 4 principles. So this time it is smaller than the original object. It is upright. Both arrows are pointing up in the same position. It's behind the mirror or other side of mirror. You want to write it that way. Okay, and its type is virtual, which means that it is inside the mirror. I can't go in there and capture it in any way. It was built from these backwards tracing dashed lines. That's how you know it's virtual. And so the kind of place where you'd maybe use a mirror like this is you want to see more area than you can see. In doing that, you're going to sort of shrink the objects, but expand your area. So where you might see these is where people are kind of on a blind corner. They'll put out a curved mirror like this so they can see around the corner before they pull out. Security mirrors are like this. Those are just 2 places I can think of where you'd see that. So I'm going to put security mirror like up in the corner of a store or an entrance to a building, something like that, to allow you to see more space than you would generally see from your position. And that's it. So I just wanted to introduce these today because we hadn't talked about mirrors yet. It's good if you practice being able to do these on your own, replicate it, see if you get the same thing I did, and then I'll leave some stuff with you to continue to practice and let you know what to do next. But I have a phone call to return, as you can hear, so I'm going to call it a day on that. So for now, hopefully that makes sense in your note, and we will talk again soon. So sorry that was a little bit abrupt, and that will be it for your set of physics lessons. Okay, talk to you soon.